Hello students, welcome back to the math class. Today we are going to start exercise 12.2 of chapter Introduction to Three-Dimensional Geometry. We are going to start today. The topic is distance between two points. Distance between two points already you have covered in the class 10 in the chapter of coordinate geometry, where we have covered a two-dimensional geometry, as well as in the class 11 also. In the class 11, if you have covered a chapter of straight line, in that also you may have learned about the distance formula once again. Now we shall see how the distance formula is given for three-dimensional geometry. As you know that in three-dimensional geometry, now there are three different axes are there. So we can say that here coordinates will be also three, which will represent the three different axes. For example, in the two-dimensional geometry, we have the coordinate normally in the form x comma y. For example, if I write down here x comma y, so I can say that this represent a two-dimensional geometry or a two axis over here. But suppose if I take here one more coordinate, for example, suppose if I take here x, y and z, x, y and z, then I can say that the first coordinate, which is x, that represent the x-axis, y represent the y, sorry, y-axis, and z represent the z-axis. So three different coordinates representing the three different axes. Now suppose such kind of 2 points we have given to us, and we need to find out the distance between them. So how shall we find out? That formula is given over here. You can check. The distance formula is written. Distance AB is equal to under root of in the bracket x1 minus x2 the whole power 2 plus y1 minus y2 the whole power 2 plus z1 minus z2 the whole power 2. In place of z1 minus z2 or y1 minus y2, you can write down y2 minus y1, z2 minus z1 or x2 minus x1. Okay, because square is there, so if the difference is coming negative against because of the square, it will become positive. So here x1, y1, z1 are the coordinate of the first point, while x2, y2, z2 are the coordinate of the second point. Okay, now one note is there. That note already we also have covered in the class 10, but once again we can see note is given like that. 3 points p, q, r are collinear if, suppose if we have given that 3 points and we want to show that 3 point sorry, 3 points are collinear, then the conditions are given over here. PQ plus QR is equal to PR, means PQ is here the distance from P to Q points. Okay, so suppose if I draw one line over here and I want to prove that the 3 points are collinear, and suppose that the points are in this sequence. This point is P, this is point given as Q, and this one is given as R. Now you only think, if these 3 points are collinear, then PQ and QR, if you add, then it will be definitely equal to PR. So we can say that if the 3 points are collinear, then definitely the sum of the two will be equal to third one. So we have created here three different possibilities. One is PQ plus QR is equal to PR. Second one is PR plus QR is equal to PQ, and third one is PQ plus PR is equal to PQ. Okay, so these three different possibilities we have mentioned over here. You need to think only the sum of two, which would be equal to the third one. Now I will show you the first question, one or two part, how to find out the distance between them. However, these questions are very simple for you. So first of all, let us see the first part. In the first part, we have given that first point I am supposing as A, that is 2, 3, 5, and second point is given as B, that is 4, 3, 1. Okay, now we need to find out the distance between these 2 points. So first point coordinate I am supposing here x1, y1, z1, and second I am supposing here x2, y2 and z2. Now let us find out the distance between them. So we can say that therefore distance AB is equal to, in the under root we shall find out the distance difference between the x coordinate, y coordinate and z coordinate. So that will be 4 minus 2 whole power 2 plus 3 minus 3 whole power 2 and 1 minus 5 whole power 2. Please keep the pattern in the same manner. Here I am subtracting the first coordinate from the second. Okay. So 4 minus 2, that will be here 2. So that is remaining here 2 square plus 3 minus 3, that is 0 square, and 1 minus 5, that will be minus 4. Now if I solve it little further, so it would be 2 square is 4, 0 we can leave it, and minus of 4 square will be 16. So this is coming as under root of 20. 20 we can write down as sum of the factors of 20 will form the pair. So we can write down this one as 2 into 2 into 5. Okay, 2 and 2 will be going to form the pair here. So value of distance AB is coming as 2 under root of 5 units. Okay, always write down the distance or any type of length in the form of unit only. For example, if you are mentioning the area, then mention as a square unit. Okay, one more question I will show you. That is part number second. It is given here minus 372 and 24 minus 1. So let us see the second part over here. Second part, first coordinate is given here as minus 3, 7 and 2. This we can suppose as point P, and second point I am supposing as Q. So point Q is given here as 2, 4 minus 1. So Q point is 2, 4 minus 1. Okay, let us find out the distance PQ. Now first, from minus of 3 we can subtract 2. So minus 3 minus 2 whole power 2 plus 7 minus 4 whole power 2, and plus from 2 we are subtracting minus 1. So minus minus will become here plus whole power 2 again. Now further we can write down in the under root minus 3 and minus 2 will become minus 5, and square of minus 5 will be here 25. 7 minus 4 is 3 and square of 3 is 9. Again 2 plus 1 is 3 and square of 3 is 9. So 25 plus 16, sorry 25 plus 18, so that will become here 43. So we can say that therefore distance PQ is equal to under root of 43 units. This will be answer. Okay. Now let us see the question number second. In the second question, we have given that, yes, see, they are saying show that the points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 are collinear. Okay. So let us see how we can prove it. The condition of collinear, I have told you earlier, the sum of the two distances should be equal to the third one. Okay. However, in the two-dimensional geometry, to prove that the points are collinear, we may have used the section formula also. But here, right now, we have to use this condition only. Okay. So let us see. First of all, here I will take the 3 points name as let given points are first point I am supposing P, that is minus 2, 3, 5. Second I am supposing Q, 1, 2, 3 and R, that is I am supposing here as 7 0 minus 1. Okay, so first one by one I am finding the all the three values. So first I am finding the value of PQ, then QR and then PR. So first we shall find out the value of PQ. PQ is equal to under root of, now since you are habitual with the distance formula, so little bit I am doing it directly, minus 2 minus 1 whole power 2, then 3 minus 2, that is whole power 2, and plus 5 minus 3 whole power 2. Okay, now further we can solve it. So under root of minus 2 and minus 1, that is minus of 3 and minus of 3 square will be 9. 3 minus 2 1, square of 1 is 1, and 5 minus 3 2, square of 2 is 4. 9 plus 1 10, 10 plus 2 12. So it is coming basically under root of 12. Under root of 12 we can write down here as 2 into 2 into 3. Okay, so one pair of 2 is complete. So that 2 we can take outside. So finally we'll get the value of PQ. So we can say that therefore value of PQ is equal to 2 under root of 3 units. Okay, now let us find out the value of QR. The second value is QR is equal to under root of, now 1 minus 7 whole power 2 plus 2 minus 0 whole power 2 and 3 plus 1, because minus minus become plus. So 3 plus 1 whole power 2. Okay. Now further 1 minus 7 will be here minus of 6, and minus of 6 whole power 2 will be equal to 36 plus 4, and again 3 plus sorry, 3 plus 1 4, so that is 16. 16 plus 4 20, and 20 plus 36, that will become here 56. 56 if we make factor, then that will be 7 into 8, and further 8 can be more factorized as 2 into 2 into 2. 7 into 2 into 2 into, okay. Now one pair of 2 is complete here, so that we shall take outside. So we can say that therefore QR will be equal to, I think we are doing some mistake, once we can check, because this is coming 2 under root of 3. So one we can check once again. Let us see, is there any calculation mistake are there. Q and R if we are finding it. So 1 minus 7, let me check the point first. 1 2 3 7 0 minus 1 and minus 2 3 5. So 1 minus 7, 2 minus 0 and 3 plus 1. Okay, 4 square is 16, 2 square is 4, and 1 minus 7, it is minus of 6. Once we can check PQ here. So minus 2 minus 1, 3 minus 2 1, and 5 minus 3 2. Yes, here we have done the mistake. 5 minus 3 2, and square of 2 will come here 4. Here small mistake is there, because relevant terms were not coming. That's why I thought some mistake we are doing definitely. So we can rub this one. Wait a minute. Here we have done the calculation mistake. Yes. So this will be 3 minus 2 1, and 5 minus 3 is 2. Square of 2 is 4. So 9 plus 1 10, 10 plus 4 14. So this is coming as under root of 14. Okay. So this one also I will rub. This is coming as under root of 14. Now it is right, because the two different terms was coming. Yes. Okay. Now here you see we are getting is 2 we are taking outside. So this will be 2 under root of 14 units. This is the value of QR. Okay. Now we shall find out the value of PR. So see what are the points P and R given here. P is minus 235 and R is 70 minus 1. So now we shall find out. Here I will write down the point P and R. P is given minus 2, 3, 5 and R is given here as 70 minus 1. Once we will check minus 235 and 70 minus 1. Okay. Let us find out the value PR. So PR is equal to under root of minus 2 minus 7 whole power 2 plus 3 minus 0 whole power 2 and 5 plus 1 whole power 2. Minus minus became plus. Okay. Now let us simplify this one. So minus 2 and minus 7, that is minus 9, and square of minus of 9 will be equal to 81. So this will be 81 plus 9 and 5 plus 1 6. Square of 6 will be 36. So if we add all of them, 81 plus 9, that is 90, and 90 plus 36, that will be equal to under of 126. Okay. And 126 if we factorize. So 126 if I divide by 2, remaining is 63. So 7 9s are 63. So 2 into this will be 3 into 3 into 7. I think this will come, and one pair of 3 will be completed. So that we shall take outside. Sorry. PR is equal to 3 under root of 14 units. This will be the value. Now you see, if I add PQ and QR, observe the PQ and QR if I add, so 2 under root of 14 and 1 under root of 14 will be equal to 3 under root of 14, means that will be equal to PR. So we can say that the sum of the two will be equal to the third one. Here we shall mention at the last, since PQ plus QR is equal to under root of 14 plus 2 under root of 14. So this will be equal to 3 under root of 14, and 3 under root of 14 is equal to PR. So is equal to PR. Therefore we can say that PQ plus QR is equal to PR. So we can say that therefore PQR are collinear. PQR are collinear points. Okay. Now we shall see the question number 4. In the question number 3rd, there are many parts, so that I will take in the next session. Question number 3rd and question number 5. Both the questions are little lengthier, so we can see it afterwards. In the question number 4, see what we have given to us. Find the equation of the set of the points which are equidistant from the points 1, 2, 3 and 3 to minus 1. Means, for example, suppose here one point is given whose coordinate is 1, 2 and 3, and one more point is given to us 3, 2, minus 1. Okay, for example, now there are many points in the plane which will be equidistant. We can say here some points are there whose distance, if we calculate from these 2 points, will come same. So we have to find out the equation of all those points who are equidistant from the given points. And if we put up the value of x and y over there, definitely we'll get the coordinates of that particular points. So let us see how we can find out the equation. First we shall suppose That point is here point P, whose coordinate we can suppose here as x, y and z. So first I am going to suppose the point over here. We shall draw one figure so we'll understand in a more better way. So here suppose that if I take the 2 points, this is the first one and now I am taking the second one here like this. Okay, and now suppose that here we'll draw it once again. It looks equal. Okay, so see, suppose if I say this point is P and we have given that two given points A and B. Okay, point A coordinate I am supposing here 1, 2, 3 and B coordinate we have given here as 3, 2, minus 1. And we have given that one more thing, the length of PA and PB are equal. Okay, and point P coordinate I am supposing here as x, y and z. Okay, so we have to find out the equation in terms of x, y, z who will satisfy this condition. So let us find out the equation first. First of all, we can say that since the length of PA is equal to PB, that is given in the question. Now, if I do the squaring, then also they will be equal. The square of PA is equal to square of PB, right? Because if 2 is equal to 2, the square of 2 will be equal to again the square of 2. Now, why we are doing the squaring here? Because the distance formula contains the square root. So, if we do the squaring here, we need not to apply the square root symbol. Okay, so directly we shall write down the terms inside the square root. So now let us find out the distance PA, that we can write down as x minus 3 whole power 2 plus y minus 2 whole power 2 and plus z plus 1 whole power 1. I just applied the distance formula of length PA. Only I have not put up the under root symbol on that because already the square of PA we are going to find out. In the similar way, we shall find out the length of PB here. So that will be x minus, sorry, I think I have written in place of PA the length of PB. So please ignore length of PA. Now I am writing here. So that will be x minus 1 whole power 2 plus y minus 2 whole power 2 and z minus 3 whole power 3. Okay. Now let us see how we can go further. Here, first of all, we shall open all the three brackets. Okay. So first, if I open x minus 3 the whole square by a minus b the whole square, so x square plus 9 minus 6x. Here square we forgot. And y minus 2 the whole square is y square plus 4 minus 4y. Similarly, z plus 1 that we are writing. So that will be here z square plus 1 plus 2z. Again x minus 1 the whole square is x square plus 1 minus of 2x plus y minus 2 the whole square, that will be y square plus 4 minus 4y, and the last one is z square plus 9 minus 6y. So one thing is very clear, x square, y square and z square got cancelled from these three terms. Okay, now we can do one thing. First of all, we can add the constant term. So minus of 6x minus of 4y and plus 2z. I am writing as it is here. 9 plus 4 13, 13 plus 1 14. So plus 14 as it is. Similarly, again minus of 2x minus of 4y I think this one I wrote wrong. That is minus of 6z will come. Sorry, this is minus of 6z. So by mistakenly I wrote minus of 6y. Okay. Now minus of 4y minus of 6z. And if I add this one, 1 plus 9, 10. 10 plus 4 again 14. So here also it is coming 14. 14 and 14 got cancelled, and minus of 4y and minus of 4y also got cancelled. So now we can bring the two terms on this side, minus of 6x plus 2z plus 2x and plus 6z is equal to 0. Now further, minus of 6x plus 2x, that will be equal to minus of 4x and plus 8z is equal to 0. Now we can take minus 4 common from here. If I take minus 4 common, remaining is x minus 2z will be equal to 0. So we can say that minus of 4 is going in the denominator of 0. So we will get here x minus 2z is equal to 0, or we can say that x will be equal to 2z. Okay, means here does it mean? See this equation we got. So what actually this equation can be meaningful for us? Means here the p coordinate, if we think what can be the coordinate of the point P. So one thing is very clear, the y coordinate sorry, y coordinate is 0 because we did not get the in the equation y over there. Second thing, the x coordinate is always double of the z coordinate. Means suppose if the z coordinate is 3, then x coordinate will be 6, or if the z coordinate is 5, then x coordinate is 10. Means the coordinate can be there in the form, one is here a, suppose if I say this one is 2a, this is 0, and this can be, it will come in this form particularly, we can see. Okay, next time we can start the question number 3rd and question number 5. That two questions we will finish. Thank you.